Okay, here we are. I'm going to come at you with yet another problem type. So we're still being asked to reduce fractions here. But the problem is, well, if you take a look at it, does our numerator go into our denominator? I don't think it does. Yeah, if I count by fours, I'm not going to hit 6, right? I go 4, 8, 12, right? I've already passed 6. So yeah, I'm not going to hit 6. So that means that 4 does not go into 12, but we can still reduce it. So the trick here is to find a number that goes into 4 and also goes into 6. And you kind of have to be a little creative here. Now, later on in the year, we'll develop some more sophisticated techniques on how this is done. But for the time being, we just kind of employ a guess and check method. So I'm just going to go through the numbers that I know one by one. And your knowledge of your times tables really comes into play here. So the more you know your times tables, the easier this part will be. So this is what we do. I'm going to go through my numbers one by one, and I'm going to check to see if it goes into the numerator and the denominator. Okay, in this case, well, the first number, it doesn't really work to do 1. I'm not going to divide both of these by 1. So let's try 2. So does 2 go into 4? Yes, it does. 2 times 2 is 4. Does 2 go into 6? Well, yeah, it does. It's even. So that means 2 times 3 is 6. So 2 goes into 6. So that means that I can divide the numerator and the denominator by 2. Now, the tricky thing about this method is that nowhere on this fraction do you see the number 2. You had to find that number yourself. So sometimes these questions take a little while, but as long as you're thorough and as long as you just take your time, you should be able to find a number that goes into both the numerator and the denominator. So if I complete this, well, I'm going to do 4 divided by 2, which is 2, and 6 divided by 2, which is 3. So this fraction is the same as 2/3. Okay, let's try one more example. Let's do 10 over 15. So every once in a while, when two numbers are together and you're looking for a number that goes into both of them, it's really helpful to think about your times tables. And let's think about if we had all the times tables lined up in a grid, would any of these numbers, or would these two numbers line up on the same row or column? Well, I'm thinking about my 5s. That's the first thing that comes out. I know that 10 is a multiple of 5, and I know that 15 is a multiple of 5. So right off the hop, I know that 5 goes into 10, and 5 goes into 15. So what I'm going to do is I'm going to divide both by 5, and I get, well, 10 divided by 5 is 2, and 15 divided by 5 is 3. Do one more example. Let's try maybe more of a tricky one. We'll call this one kind of the advanced type. Okay, so I'm gonna go to 12 and 30. So if I do this, well, let's have a look. I wonder, 1 obviously goes into both of them. Does 2 go into 12? Yeah, 2 goes into 12. 2 also goes into 30. So I'll do divide by 2 and divide by 2. And let's see what I get. Well, 12 divided by 2 is 6, and 30 divided by 2 is 15. And that's great. I reduced this fraction. However, sometimes you can keep going. So this isn't completely reduced. So what I mean by that is that if I kept asking myself, are there any numbers that go into 6 and 15? Well, 2 goes into 6, but 2 doesn't go into 15. Let's think about 3. Does 3 go into 6? Yeah, 3 goes into 6. 3 goes into 15 as well, right? Because 5 times 3 is 15. So what I can do is I can divide both of these by 3. See how I kept going? I can do 6 divided by 3, which is 2, and 15 divided by 3, which is 5. So every once in a while, you may come across a question like this. So always make sure that once you've reduced your fraction, make sure that you can't reduce it any further. Okay, well, good luck with page 4, and I'll be back to help you with page 5.